When we humans touch and interact with a soft object, we quickly understand how it feels and behaves. For example, doctors use palpation to find anomalies buried deep in tissue and to determine where to make incisions during surgery. But can robots do the same? In this paper, we propose a method for a robot to model a soft object sufficiently well after a few touches, so that it can simulate its behavior in very different scenarios, specifically by able to simulate contact with a rigid object that the robot has never seen before. Our approach is a blend of analytical physics and machine learning called semi-empirical simulation. On one hand, analytic physics uses complex equations match models, but calibrating these models to real sensor data is difficult. On the other hand, machine learning methods gather empirical data from experience, but don't generalize well outside of the scenario distribution. Our method combines benefits of both worlds. We learn the most challenging parts of behavior from data, but use physics to handle the parts that are better understood. In the experimental phase, we learn how the object reacts to poking at a single point. This greatly reduces the scope of learning, so we can still capture important properties of a deformable object with just a small amount of experience. During simulation, we use the shape of the object to determine how it would make contact with an arbitrary rigid object. We link the surface deformation at individual points with the Hertz contact model. And using the length point force models, we can simulate the resulting contact match. The colors in the simulation show the amount of surface deformation for a line probe that the robot has never seen before. Our tests show that this zero-shot learning approach demonstrates comparable accuracy to normal testing. In conclusion, we presented a data-efficient semi-empirical approach that simulates real-world deformable object force responses at fast speeds. In the future, we would like to use this method in planning problems, for example, packing deformable objects. Thanks for watching.